Hello guys, welcome to the channel. Here on the screen you can see what is it. It is character variable char ch. See, I have declared a character variable ch and assigned a character value to it. How I have written it, how I am showing it to you. Have you ever thought about it that how these characters are stored in our computers? How it is stored and represented in our computer memory? If we talk about computers, they only understand binary numbers, means 0 or 1s, and all the information is stored in the form of bits, either 0 or 1. Let me first tell you about integers. If we talk about integers, if we do, suppose I have declared a integer variable I, and if we use size of function to I, what it will return? Size of function is a function that takes data variables and it returns the size of that particular variable. This is I is integer variable and it will return size of 4, means 4 bytes, and 1 byte equals to 8 bits. 1 byte equals to 8 bits, means if we have I equals 5, and it will be converted into binary form. 5 will be converted into binary form, and here integer have total, let me tell you, size of int is 4 bytes, size of integer is 4 bytes and 1 byte is 8 bits. Then we have total 4 into 8. 1 byte equals to 8 bits and 4 bytes equals to 4 into 8, that is 32 bits. We have 32 bits space. What is bits? Bits means collection of ones and zeros. One bit have total length, 1 byte have total length of 8. Okay. If we convert 5 into bit of 1, let me tell you that we have 128 at 64, 32, 16, 8, 4, 2 and 1. These are decimal representation of binary numbers, and for 5 we have 128 equivalent is 0, 64 is 0, 32 it also 0, 16 is also 0, 8 is 0, 4 we will take 4 as 1 and 1 as 1, and 2 as 0 and 1 as 1. We have total 4 plus 4 bytes, means this is 1 byte size. Okay, if we have to store this number in in bytes, in 1 byte. It will be stored like this. It will be stored in this form. Okay. Understanding of how we store int is quite simple. We just simply convert it into binary number and it will be stored in the computers. Our computer or machine will do it. We don't do it. Okay. We just declared it and used it. But I am giving you some idea how it is stored. Understanding of uh, storage of int is quite simple, but in case of char, if we talk about char, you would get confused, won't you? How we store it? We store it, if we talk about char, we store it in the form of ASCII values. In the form of ASCII values. Some of my might get confused and some of might can think that अब ये क्या बोला है भाई, ये कौन सी नई चीज आ गई. But I will tell you, don't worry, I will tell you in simple words. Each character each character has its ASCII equivalent. Okay, ASCII, what is the full form? Let me tell you first what is the full form of ASCII. ASCII is American. Full form of ASCII is American Standard Code for Information Interchange. Okay, it is an encoding scheme used for communication in electronics. It is common standard for each country. If each country has different standard of code of encoding scheme, then if when they interchange the information, we got have big problems. That's why this standard is made common for all. American Standard Code for Information Interchange. Each char value is uh, encoded into these ASCII values. Okay, don't get confused. For ASCII value, I'm telling you that ASCII value is simply, in simple words, ASCII value is an integer number between 0 to 127. Means ASCII value is simple, is a number that is from 0 to 127. Means total we have 128 ASCII values, and we convert it into um, we convert it we convert the character values into this ASCII values and use it, and we store when we convert these ASCII values into this when we convert these character values into ASCII values, then after that our system will use it, and it will converted and stored in our system. Okay, and we have, if we talk about lower uppercase alphabets, means A to Z, that has ASCII values from 65 to 90, both digits are inclusive. And if we talk about lowercase a to z is 97 to 122. Okay. Let me show you the ASCII table for better understanding. Here, this is ASCII table. Here, decimal values are represented by DEC and character values are represented by char. Here, 5 has int value 53. Here, if we enter some decimal number as a character, it also has its ASCII equivalent. Let me show you. Here we can see 0 has null, 0 is used as null, and these are symbols from 0 to 31, and 32 is for space, and 33 this is negation, inverted comma. Here these are operators, and every symbol is has its own ASCII character, ASCII value, ASCII equivalent number. Okay, we have 48 that is for used for decimal equivalent, that is 48, and it is used for character 0. If we enter 0 as a character value, so computer will consider it as decimal equivalent 48, 1, 49, and so on. We have a colon and semicolon, question mark, and here we have 65, that is uppercase 65 to 90, that is A to Z, and here 97, that is A, and 122, that is Z in lowercase. Okay, and other symbols here like braces and del is represented by 127. Here if we write 5 minus 0, 5 as a character minus 0, what is its 5 is represented by 53 and 0 is represented by 48. If we subtract character value 5 minus 0, that will be 53 minus 48, that is equals to 5 as integer. Okay, and if we write char c is equals to uppercase B plus 32, it will be equivalent to value of lowercase b. Okay, means uppercase B, value of uppercase B is 66, and 66 plus 32, that will be 98, that has lowercase b. Okay, let me take you to my code editor and I will show you. I have created a file. You can here let me give you char I equals a. Let me show you. Here we have character variable, but I will print it. I is a character variable, but I will print it as an integer without typecasting it. Okay, let me show you. Let's run the code, and here it is printed. It's 97. Here it is printed at 97. Okay, if we put I equals I plus 5, then what will we have? It will be 102, means 97 plus 5, that will be 102. Means it is not A, it is the character, it has ASCII equivalent value, that is 97, and when we add 5 to it, it will be incremented 97 by 5. It will increment 97 by 5, that is 102. It will be 102. Okay. Now we can also compare these values if we have char, and we can use char ch. Ch equals capital A. We can compare each values if I is greater than ch. We can print some value. A is greater than capital A. Let me show you. Here, ASCII equivalent of A is 97, but ASCII equivalent of uppercase A is 65. You can see I have put the cursor on it, and you can see it. If we put some integer into it, and as here you can see ASCII equivalent of 5 is 53, and here is 0. Okay, 5 and 0. Printf %d I. ASCII value of 5 is I, and here ASCII value of 0 is ch. Sorry, ASCII value of 0 is 48, and 5 has 53. Let's print these values, and let me show you. Here 5 has 53 and 0 has 48. Here you can see 5 is 53 and 0 is 48. Let me print all these values using loop. Here, let me show you. Integer I, and I am printing all the values from 48 to 127. Okay, here this is our character, this is our char value. I have put %c, and for integer value I have put %d. Okay, let me print it as a table. Let's run the code. Here you can see all the symbols are printed. 0 is 48, 1 is 49, 2 is 50, 3 is 51, 4 is 52, 5 is 53, 6 is 54, and so on. All the here uppercase A is 65, and this is how uppercase letters are printed from A to Z, and lowercase letters are from 97 to here 97 to 122, and here, as I have shown you on the table, it is printed the same. Okay, so these uh, if we put p small p, if we input a small p, it will be treated as 112, and it will be converted into binary, and it will be stored in our system. Okay, our system will treat it as 112. Okay, and it will convert it into binary, and it will store it. System doesn't know that it is p. It is treated as 112. Okay, now I have shown you the ASCII values and how our character is stored. Now you can do different things from these ASCII values. For example, if I say write a function to check whether the given character is alphabet or not, you can check it. Or write a function to check whether it is in uppercase or lowercase. Okay, you can also write this function. How you will write it? You can write it that if suppose I have input some character, that is ch, if ch is greater than and equals to 97 and less than, sorry, it is greater than and equals to 64 and less than and equals to 122, means we have all the characters uppercase A to Z and lowercase a to Z, that will be from 65 to 122. Both are inclusive. Okay, if we put the condition that the given character is greater than 64 or greater than 64 and less than 123, then the ch is character ch is the alphabet, otherwise not. Okay, and when it is alphabet, you can also check for lowercase and uppercase letters.